Hello friends, welcome to Math Succeed Algebra 1 tutorial. Numbers are fundamental building blocks of mathematics. The numbers are classified into different sets in math based on some properties. There are many classifications possible, and one such classification is rational numbers and irrational numbers. So in this lesson you will learn about rational and irrational numbers. You're going to learn about rational number set, subsets of a rational number, which are natural number, whole numbers, and integers. And then you're going to learn about irrational numbers. After completing the lesson, you should be able to identify a number and its number set. There are real numbers which you can write in the form a divided by b, where b is not equal to 0. It means you can write the number as fractions. For example, 3 by 2 is a rational number. You can write a rational number as decimals. So 3 by 2 can be 1.5. If a rational number is written as decimal numbers, then its decimal part should be terminating. And the terminating part is very important. Suppose you divide 10 by 3. So if you divide 10 by 3, which is a rational number equal to 3.3333 and 3 repeat itself. So a rational number written in decimal form must have repeating decimal part like 3, which is repeating itself. You can indicate the repeating digits by placing a bar on top of it, and this bar indicates that the number or the numbers are repeating itself. Now before we begin about subsets of rational numbers, a bit about sets. So any set is a collection of elements, and in our case it is numbers. So there are two ways to show numbers in a set. Show all elements within a list, or for example a set of even numbers is 2, 4, 6, 8. Show set in a set builder form, which picks an element from set and define its property or restrictions. So we can say something general about the set. For example, x in R such that x is greater than 0. In other words, it is a statement x is a real number such that x is greater than 0. All number belonging to a set called real numbers, and the real number set is R. So rational numbers are subsets of real number, and the set is shown with the letter Q. The rational number set contains positive numbers, negative numbers, and 0. This subset of rational number, which contains positive number, negative number, and 0, is called integers. This subset of rational number is denoted by letter Z, and you can represent integers in set builder form as x in Z such that x is less than 0, or x is equal to 0, or x is greater than 0. Examples of integers are -2, -1, 0, 1, 2, 3, and so on. The integers also have a set or a subset called whole numbers. Now it is denoted by letter W and includes all numbers that are greater than or equal to 0. It contains all positive numbers and 0. So there are no negative numbers. Since integer is a subset of rational numbers, whole number is also a subset of rational numbers. So you can write this in set builder notation, for example as x in W such that x is greater than or equal to 0. Examples of whole numbers are 0, 1, 2, 3, and so on. The whole number set is a subset, has a subset called natural numbers or counting numbers that we use in our everyday life. Note that the whole number itself is a subset of integers, and rational numbers. The set of natural numbers is denoted with letter n, and in set builder notation it is the statement set of all numbers that are greater than 0, and we can write as x in n such that x is greater than 0. You can write any integer, whole number or natural number in a by b form where b is not equal to 0. For example, the integer -3 can be written as -3 by 1, and the natural number 5 can be written as 5 by 1, which is same as 5. So now we talk about irrational numbers. There are numbers that cannot be written in a by b form where b is not equal to 0. These numbers are called irrational numbers. The irrational numbers are those that cannot be simplified because in its decimal form it is not repeating, non-terminating numbers. For example, square root of 2 is an irrational number. If you use your calculator to simplify square root, it results in this number, which is a non-repeating and non-terminating number. Similarly, pi is an irrational number with non-repeating and non-terminating digits. The famous Euler constant E, which is equal to 2.7182818 and so on, is another famous irrational number. There is a special number called complex number, about which you will learn in future lessons, not right now. So let's recap everything. In this lesson you learned about rational numbers and its subsets, integers, whole numbers and counting numbers, and you also learned about irrational numbers with examples.